Hi student, good afternoon. How are you all? Good. So all are fine? Nice. So this is our first class. My name is Warsha and I will teach you physical science. Okay? Don't worry, we will enjoy. Yes. So first of all, please introduce yourself to me. Yes. Only name, okay? Yes. Himshika, okay? Swati, Suman, Bittu, Anjali, Sandhya, Shorana Bhutia, Ramesh, Sonam Bharti, Manish, Ashish, yes, Dipali Puri, alright. Okay, you all the students have such a good name. So just such a good name you have now. So just be active in the class and response to in the class here whenever I will ask any questions. So have you ride student a bicycle? Yes. Have you ever ride? Yes. Yeah. Okay. All the students have ride? Yes. Nice. Okay. So students, have you ever applied brake whenever you see any other vehicle crossing or when the traffic light is red? Yes. Have you ever brake it? Yes. Suppose you are going with a bicycle like this, and suddenly you see the traffic lights. Then have you ever brake it? Yes. Okay. Good. And why is it so? Why you have applied brake? To follow instruction? Okay, Simon, that's good. We should follow instruction. The traffic lights. Yes. Other than that, yes, so that you will not get an accident. Okay, nice. All right. Yes. So students, do tell me that have you ever felt difficulty on walking or running in wet floor or in smooth or slippery floor? Why is it so, student? Have you ever feel difficulty? Yes. Okay. And why is it so? Why we feel so difficulty? Yes. Because floor gets slippery and there is risk of falling down. Yes, good. And yes, Suman, your point? Because you might falling down, right? Yes, good. So good responses given by you all, student. Yes. Now student, just give me 1 minute, okay? Now observe me very nicely. What is in my hand, student? Ball. Yes, good. Now what I will do, I will push it. I will do this. Yes. What I have done, student? Yes, come on. I have pushed the ball. Yes, now I will push the ball to you or like this. Now what I have done now? Yes, I have pushed the ball from the opposite direction, right? Yes, nice. That's great. Yes. So students, what they have observed, what I have done. Yes. You have observed that when the ball, I just throw it like this. Then how it stopped it, right? Yes. So the object stopped moving after a few seconds, right? Yes. So if they think that some kind of force is acting on the object opposing its motion, do you think so, student, that when I just give me when I just see, when I throw the ball and after a few seconds when it stops, then something is there which stopped the ball, right? Why? What was that, student? Why it has stopped? Yes, what's the reason? You have already know that this ball has gone because of the force, but why it stopped? What's the reason? Yes, Because of friction. Yes. So today we are going to study about friction only. Okay, students? Yes. So force is acting against the object, and that against the object is known as friction. Yes. So friction is a force that acts against an object. This is the ball. This is like running, and one friction applies here which makes stop the ball, which makes the ball in rest. Right? Yes, good. Now, friction is a type of force that resists the movement of one object over another. It acts against the motion of the object. Now, if you apply force, if you apply force along the left, friction acts along the right. See, if I apply, this is a left, right? If I apply in the left direction, then friction will come the right direction, and if I apply the force in the right direction, then friction will apply in the left direction. Okay, so always friction occurs in the opposite direction. So if you apply the force along the right, the friction acts along the left direction. In both cases, the force opposes the motion of the object. The force of friction always opposes the applied force. Friction can't be happen when it is in rest. Whenever I will apply any force, then only friction can occur. So when you ride the bicycle, whenever you are riding the bicycle, and when you brake it, the bicycle, at that time friction occurs, because if it will apply friction from the opposite direction, you are going in front side, it will apply friction in the back side. So the force of friction always opposes the applied force. The force of friction acts between the surface of the object and surface of the hand. Okay? The force of friction acts between the surface of the object and the surface of the hand, whatever kind of the surface are there. That is why we find difficulty in smooth or wet surface. Okay, students? Yes. Now, this is the ball. Now, what you have to do, you have to enlist real life examples where the force of friction can be in use. Yes, you have to give real life example where you are seeing the force of friction. Yes. Comes up with your example. In bicycle, okay, fine, that I have told you. And then okay, yes, good. Sneha, nice. Dipali, okay, yes, you have given a lot of example of related friction, that's nice. Now, please, friction is an dash force. Yes. Yes. Against the force. Okay, fine. Now, friction opposes the dash between the surfaces in contact with each other. Yes. Friction opposes the dash between the surfaces in contact with each other. Direction. Okay. Yes, good. Okay, yes, so friction is an applied force, student. Okay, yes, and friction opposes the motion of the objects between the surfaces in contact with each other. Okay, yes, any doubt? Okay, fine. Now do tell me, student, how you feel when you find a smooth surface of the road in bicycle. Yes, how you are feeling that time? Smooth. Yes, it is easier to get ride with speed. Yes. And how you feel when the road are not good, I mean rough road. Yeah, this is smooth road and this is rough road. So how you feel while you are riding in this type of road? Yes, it gets tough to ride a cycle and also the speed gets slow. Yes, Dipali, Sweta, Swati, Manish and Swati. Yes, please be active with two. Yes, so you find difficulty. Yes, good. Now observe, now watch one video so that more clarity you will get.
Wow, a boot camp. It's so exciting and so terrifying at the same time. Sure, you trust me.
Here's a cube that's placed on the table. We know that if we are pushing the cube in this direction, then the force of friction slope on a table like this and mark a point somewhere on it. Now from this point, let a small cylindrical shaped object move down. You will see that it reaches a particular point and then stops. Next, place sandpaper right under the slope and leave the object from the same point as before. What do you notice? You will see that the distance covered by the object is lesser in the second case. And you probably know why. The surface on which the object rolled was rougher in the second case. And clearly, the force of friction was more. Why is friction caused though? It is caused due to the irregularities on the two surfaces in contact. What do I mean by irregularities? Now, even though the table looks...
Yes, student. Please explain what you have observed. Yes, you observed that the surface was smooth, the objects moved smoothly and quickly. Okay, fine. Yes, Sandeep. When rough sandpaper was placed on the table, the object slowed down. Okay, fine. Then, yes. Now student, can you guess the reason behind this fast and slow, rough and smooth movement of the object? Why this is happening? That it is working in the good and the smoothly in the smooth surface, but not friction occurring in the rough surface. Yes. Why? What happens, student? Yes. Yes, I am asking students that if they can guess the reason behind this fast and slow, rough and smooth movement of the object. Yes, it happened because of the surface. Right, very right. Today we are going to study about friction, right? Yes. So friction is caused by the irregularities on the two surfaces in contact. Even those surfaces which appear very smooth have a large number of minute irregularities on them. Irregularities on the two surfaces lock into one another. When we attempt to move any surface, we have to apply a force to overcome interlocking. Okay? So even the surface is smooth, then also we have to apply a force. We have to apply, to move a surface, we have to apply force to overcome that interlocking. If we will not apply force, then we will fall down, even in smooth surface also. And on rough surface, there are large number of irregularities. In smooth surface also there are irregularities, and in rough surface also there are irregularities. But in smooth surface, irregularities are less. In rough surface, irregularities are more. And for smooth surface also, we have to apply force to overcome interlocking. And on rough surface, we have to apply a greater force. So the force of friction is greater if a rough surface is involved. Alright, do you have any doubts, student? If you have, then please ask. Don't hesitate, okay? Yes. Now, how surface irregularities the friction, student? Yes. How the surface irregularities affect friction? How? Yes. Okay, because in smooth surface also we are getting irregularities that applying force, because friction always apply in the opposite. Very good, Praful. Yes, Dipali, nice. Yes, so in smooth surface also we have to apply force, and rough surface also we have to apply force, right? Good. Now student, fills up. Okay, friction depends on the dash surfaces and the dash of surfaces. Yes, friction depends on the dash of surfaces, on the rough of the surfaces. Yes, very nice. Good. Okay, now let's move further. Suppose students, this is my chair, right? Now I can easily push like this, right? Yes. Now, if I sit in this chair like this, and I will tell you, or one of the student to tell, if I will tell that please come and slide and do drag to me, then will it be easier, student? Yes? Will it be easier? Or suppose if in a mat, one person, if in mat no one has sitten, then it will be easier. Or if one person will sit, then it will be easier to drag. Yes, when no one sit, then it will be easier, right? Yes, very good. So, have they ever tried to push a heavy objects like a box? Yes, have you ever tried it? Okay. Okay, fine. So what do you find? That is easy to drag a box? No? Yes. Okay, so is it easy when it is in rest or when it is in motion? When is it in rest? Okay, good. Nice. Now students, please observe the video again, okay?
Thanks for tuning into the SNN Science News Network. Tonight in the Situation Room, we have 4 guests who will discuss tonight's hot topic on friction. As we know, friction is the resistance created between 2 surfaces. Tonight we would like each one of our guests to discuss one type of friction. Mick, let us start with you.
Well, alright. Why not start off tonight's discussion on rolling friction? Rolling friction is when one surface rolls over another. We see this every day with cars and skates.
Another type of friction is sliding friction. Sliding friction occurs when 2 objects slide over one another. For instance, when your friend asks you to pass the book and you push it towards them, that is sliding friction. This also occurs when skiing and just going down the slide.
I guess static friction is next. Static friction is the starting friction between 2 objects when no motion occurs. The object will move once and a force is exerted on the object. That might be why that furniture gives me such a hard time, and here I thought it was because I was getting too old to move furniture.
Finally, there is fluid friction. Fluid friction occurs between objects and a liquid or gas. A resistance causes objects like baseballs to slow down. Swimming in a pool is an example of fluid friction, as you feel the water exert a force against the direction you are traveling.
That is all the time we have for
Yes, student. So what you have observed in this video? Yes, you have observed 4 types of friction. That's good. And that is sliding, rolling, static, and one more? Yes? Okay, no problem. So what we have studied, what we will study now? Types of friction. Good. So the force required to overcome friction at the instant or an object starts moving from rest is a measure of static friction. Now, the force required to keep the object moving with the same speed is a measure of sliding friction. So, number 1 is sliding friction. When suppose that washing machine starts sliding, the contact points on its surface do not get enough time to lock into the contact points on the floor. So, the sliding friction is slightly smaller than the static friction. And we find it somewhat easier to move the chair already in motion than to get it started, right? Yes, and we find it somewhat easier to move the chair already in motion than to get it started. Yes. Now, give me daily life examples where you are seeing that both type of frictions are occurring every day. Yes. Okay. Static and sliding friction both. Yes, very nice. Good. Now, sliding friction is always slightly smaller than friction. True or false? True. Good. Now, let's recapitulate our class. Let's end. About friction and its type, sliding and static friction we have studied. Now, please answer. Friction is a type of force that resists the movement of one object over another. True or false? Yes. Type of force that resists the movement of one object over another. True. Yes. This is your homework, where Anamika has to push a lighter box and Seema has to push a similar heavier box on the same floor. Who will have to apply larger force and why? Why do we slip when we step on a banana peel? And this is your activity. Watch the YouTube videos and make a model of sliding friction. Thank you, students. Have a very wonderful day. Okay? Bye-bye. Take care.